Welcome back to the deep dive. It is February 8th, 2026, and if you've been watching the AWS feeds, you know the last 2 weeks were not just busy.
No, exhaustive is probably the right word.
Exhaustive. We are looking at a stack of 94 separate announcements.
And these aren't small things. We're not talking UI tweaks.
Not at all. We're talking about fundamental shifts in compute, in generative AI, and even in the basic security that holds the whole cloud together.
You know, what really stands out to me looking at this whole list is a theme. It's a move from possibility to reliability.
Okay, break that down.
Well, for the last couple of years, it's been this, explosive, what can Gen AI do phase? Can it write a poem? Can it generate some code?
A demo phase.
Exactly, the demo phase. But now, when you look at updates like Claude Opus 4.6 or the new Bedrock AgentCore features, the whole conversation has shifted.
To what?
To how do we make these things actually work reliably in a production environment without a human constantly holding their hand?
That is a critical distinction. It means you need a totally different set of tools.
And different hardware, which we'll get to with the Blackwell and Xeon 6 updates.
And it requires much stricter protocols, which I think we see with the new MCP updates.
Exactly. The theme is granularity and control.
Mm.
AWS is giving us the actual knobs and dials now.
All right, so here's our plan. We are going to start at the top of the stack, generative AI.
Claude Opus 4.6 and those big Bedrock AgentCore Browser updates.
Then we're going down to the metal. We've got the G7e instances with NVIDIA Blackwell.
The new Intel Xeon 6D instances. Massive local storage on those.
And the M4 Max Mac instances after that.
We have to talk about developer experience. The model context protocol updates are trying to solve what I call the vibe coding problem.
I like that vibe coding. We'll definitely get into that. And finally, we'll wrap up with the backbone.
Infrastructure, data, networking, DynamoDB, CloudFront MTLS. A lot to cover.
Let's get right into it then. Section 1, generative AI and agentic workflows.
So let's start with the big one. Claude Opus 4.6 is now on Amazon Bedrock.
Right, and Anthropic is pushing this hard as the world's best model for coding and enterprise agents.
We hear world's best every week.
We do. But looking at the specs, especially around the context windows and reasoning, there seems to be some real substance here.
There is. We're looking at 200,000 token standard with a preview for a full 1 million tokens.
And the context window is the headline number. But I think we need to deconstruct what that actually means for an engineer day to day.
Yes. A lot of people hear 1 million tokens and they just think, oh, great, I can upload a whole book.
Right.
But in a coding context, 1 million tokens is the difference between doing arg retrieval augmented generation and doing what you might call whole context reasoning.
Okay, let's break that distinction down. In a normal RAG workflow, if I have a huge legacy code base, I'm basically...
You're chopping it up.
Right. I'm chopping it into little snippets, putting them in a vector database, and then just hoping the system pulls the right snippet when I ask a question.
Correct. And that is where the fragility is. If your retrieval step misses the one file where a specific variable is defined, the model just hallucinates. It guesses.
But with a 1 million token window.
You're not retrieving snippets anymore. You're loading the entire module. The documentation, the dependency tree, the unit tests, all of it goes into the model's active working memory.
So the model isn't just looking at the one file I'm editing. It's aware of how that file connects to the database schema that's defined in a completely different directory.
Precisely. And this allows for what we call long horizon tasks.
Meaning?
If you tell an agent, refactor this authentication module to use OAuth instead of basic auth, that's not a single generation task.
No, that's a huge project.
It involves checking references across 50 files, updating tests, making sure you don't break anything. Opus 4.6 is specifically tuned for that kind of multi-step stateful reasoning. It can plan a whole trajectory of edits, not just predict the next word.
Which leads right into this idea of agentic workflows. The announcement says Opus 4.6 is designed to spin up subagents. What does that actually look like? Is it spinning up new EC2 instances?
No, it's a software abstraction. Think of it more like a recursive function call, but for reasoning.
Okay.
When Opus hits a really complex problem, instead of just trying to solve it linearly, it can basically say, okay, I need a sub-process to analyze this database schema, and another one to map all the API endpoints.
So it delegates.
It delegates these cognitive tasks to instances of itself, the subagents, and then it aggregates their findings and synthesizes a final solution. It's mimicking how a human engineering team works.
That reliability is the whole game.
Yeah.
But, an agent is only as good as the tools it can actually use.
Exactly.
Which brings us to the Bedrock AgentCore Browser updates. To me, this felt like the most significant under-the-radar announcement of the whole batch.
AgentCore is the sleeper hit of the whole Bedrock ecosystem, I think.
For anyone who hasn't used it, what is it?
It's essentially a secure, headless browser environment that lets your AI agents interact with websites.
So web scraping.
Until now. Yeah, mostly simple scraping. But these two updates this week, browser profiles and custom extensions, move into a whole different category. We're talking serious enterprise automation now.
Let's start with browser profiles. The problem this is solving is what I call the login loop, right?
Exactly. Anyone who's written a Selenium script or a Puppeteer bot knows this pain.
Oh, yes.
You write a script to scrape a dashboard,
Yeah.
it logs in, it hits 2FA, the script fails. Or, even if you solve that, the session times out, and the next time the bot runs, it has to log in all over again.
It's slow, it's brittle, and it probably triggers a million security alerts.
Because you have a user logging in 500 times a day.
So how do browser profiles fix that?
It adds persistence. You can now authenticate a session one time manually or through some secure flow, and then you snapshot that entire state. The cookies, the local storage, the session tokens, you save that as a profile.
So the next day, when the agent spins up to run its report, it doesn't log in.
It just loops the profile. It effectively resumes the session.
And that cuts the setup time from minutes.
Down to tens of seconds. It also drastically cuts the load on your identity provider. If you're building an agent to navigate some, creaky old internal legacy portal, this is a complete game changer.
Speaking of internal legacy portals, that's a perfect segue to the other feature, custom browser extensions.
Right.
At first, this sounds like a consumer thing, like, oh, I can install an ad blocker.
But in a corporate context, extensions are often mandatory.
That's true. If you work at a big company, IT has probably pushed a bunch of extensions to your machine.
Maybe it's a password manager or a special tool for your proprietary CRM or a compliance extension that has to tag data.
So if you wanted to build an agent to automate something in that CRM, you were stuck. The agent's browser didn't have the extension it needed to even render the page right.
Exactly. So by letting you upload your Chrome-compatible extensions to S3 and then just inject them into the AgentCore session, AWS is making sure the bot sees exactly what the human sees. It closes that gap.
And yes, I suppose you can also use it for an ad blocker.
Which is actually a performance optimization.
How so?
Well, if your agent is scraping news sites or public data, blocking all those ads and tracking scripts can cut bandwidth and render time by 50% or more. It literally saves you money on compute.
Let's shift to the structural updates in Bedrock. Structured outputs are now generally available for Claude 4.5 and some open-weight models. We've talked about this before, but remind us why this is so critical.
Because probabilistic models are, by their nature, terrible at being deterministic.
Right.
If you're building an app that needs a JSON response to pass to an API, you need that JSON to be perfect. Valid syntax, correct keys, no weird trailing commas.
And historically, we had to solve this with prompt engineering. Please return only JSON. Do not say, here's your code.
And half the time, it would still say, sure, here's the JSON you requested.
Yep.
And then your parser would break.
Every time.
Structured outputs moves that validation into the model inference layer. You define a JSON schema, a strict contract of what the output has to look like, and the model is physically constrained to only generate tokens that fit that schema.
It just eliminates that whole class of errors. It turns the LLM into a reliable function call.
That's exactly what it does.
Okay, wrapping up Gen AI, let's look at SageMaker JumpStart. The model garden just keeps growing. DeepSeek OCR, Minimax M2.1, Qwen 3.
The diversity is the story here. I mean, DeepSeek OCR isn't just another LLM. It's a visual text model built specifically for compressing and understanding document structure.
So for processing invoices, PDFs, that sort of thing.
Exactly. It's a specialized tool that will outperform a general model on those tasks. And then you have things like the NVIDIA NIMs.
These are specialized microservices, right?
NIMs, yeah. NVIDIA Inference Microservices. They're containerized models, super optimized for NVIDIA hardware. And the ones released this week are fascinating because they're so domain-specific. Protein MPNN for protein design.
And Cosmos Reason for physical AI. What is physical AI?
It's models that understand physics, spatial relationships, robotics. It implies we're using SageMaker for more than just chatbots. We're using it to generate lotion pads for robots in a warehouse. It's a real glimpse into embodied AI.
Okay, let's shift gears. Section 2, the hardware refresh. All these agents and models need to run on something powerful, and AWS just drops some heavy iron. Let's start with the G7e instances.
The G7e marks the official arrival of the NVIDIA Blackwell architecture on AWS. These are powered by the NVIDIA RTX PRO 6000 8th generation, specifically the Blackwell Server Edition.
For those of us who track the model names but maybe not the chip architectures, why is Blackwell such a big leap over the last generation over Hopper?
It really comes down to two things: interconnect bandwidth and optimization for inference. With the last generation, we kind of hit a point where the chip itself was faster than the data pipeline feeding it. You have these massive GPUs just sitting there, waiting for data to be copied from memory. Blackwell introduces a huge upgrade in that interconnect speed.
So it's widening the highway to the chip.
Significantly. And notice how they're positioning the G7e. They're inference optimized.
Right, not for training.
We talk a lot about the huge training clusters, the P5 instances that build a GPT-4. But once that model is built, you have to run it. You have to serve it to millions of users.
Yeah.
That's inference.
And the G7e offers up to 2.3 times the inference performance of the G6e.
Which is a massive jump in unit economics.
Absolutely. If you can serve more than double the requests on a single box, your cost per query just plummets.
Exactly. And it's designed for spatial computing and agentic AI, which ties right back to our first topic. If your agent needs to hold a giant context window in memory and reason very quickly, you need high-throughput inference chips like this.
Okay, so NVIDIA grabs the headlines, but the CPU updates this week were just as important for more traditional workloads. We saw the GA of the CAI'd, MEI'd, and R8 instances.
This is the big Intel Xeon 6 refresh. But the most important letter in those instance names is the D.
D for disk.
For local disk. These instances come with up to 22.8 terabytes of local NVMe storage.
Let's just pause on that number, 22.8 terabytes local.
It is an absurd amount of very, very fast storage. To get why this matters, you have to look at the latency hierarchy. In the cloud, we're all used to EBS, Elastic Block Store.
Which is network attached.
Right. It's incredibly reliable, but every read-or-write has to go over the network. That adds latency. Milliseconds of it.
For most web apps, that's fine. But for high-performance stuff?
For a high-frequency trading engine, or a giant in-memory cache like Redis, or a vector database that's serving an AI agent, network latency is the absolute killer. Local NVMe storage is physically on the motherboard. The latency is measured in microseconds.
So who's the target for these D instances?
Anyone running a distributed database. Think Cassandra, MongoDB, ScyllaDB. These databases manage their own redundancy. They don't need the safety of EBS. They need raw I/O speed. With 22 terabytes of local storage, you can keep huge data sets right on the node and eliminate that network bottleneck for storage ops.
And the Xeon 6 chips themselves?
They're giving you about a 43% performance boost over the last gen. But really, the story here is the I/O. It's AWS acknowledging that data gravity is a real thing. You have to bring the compute to the data, and the fastest place for that data to be is right next to the CPU.
Okay, let's move over to the Apple ecosystem. We have the M4 Max Mac instances now generally available.
This is huge for CI/CD pipelines for any mobile developer.
Because if you're building for iOS or iPadOS or the new Vision OS, you have to build on Apple hardware. There's no way around it.
You can't just spin up a Linux Docker container and compile an iOS app. Nope. You need macOS. For years, this meant having a closet full of Mac minis humming away in your office.
AWS Mac instances moved that to the cloud.
And the M4 Max is just the latest, fastest version. It's offering about 25% better build performance than the M1 Ultra.
In a CI environment where you're running hundreds of builds a day, cutting 25% off each build time is massive. That's a much faster feedback loop for your developers.
And especially for Vision OS. Building for the Vision Pro is really computationally expensive. The simulators are heavy. The assets are 3D. The M4 Max gives you the horsepower to make those build pipelines actually viable in the cloud.
All right, let's move to Section 3, Developer Tools and Modernization. We've covered the agents and the hardware. Let's talk about how we actually control them. The updates to the Model Context Protocol, or MCP, are fascinating.
This is one of my favorite updates because it directly addresses the Wild West nature of AI coding right now. It attacks this problem of vibe coding.
Describe vibe coding for us.
It's when a developer gives a vague instruction to an AI, make me a website, and the AI just hallucinates a whole stack. It picks some random libraries and generates code that looks right, but it might be totally insecure or architecturally unsound.
Great for a quick prototype.
A nightmare for production engineering.
So how does MCP fix this?
MCP is a standard protocol. Think of it like USB, but for connecting AI to your tools. The update this week introduces deployment SOPs, standard operating procedures, right inside the MCP server.
So instead of the AI just guessing how to deploy something.
You give it a structured natural language runbook,
Mm-hmm.
a checklist. You say, when I ask to deploy, you must follow these exact steps. 1, verify the AWS credentials. 2, run CDK synth. 3, check the output against our security policy, and so on.
It turns the AI from a creative writer into a compliant junior engineer that's just following a checklist.
That is the perfect analogy. It bridges that gap between chat-based coding and rigorous DevOps. It lets a platform engineering team define the golden path for deployment and bake it right into the AI assistant every developer uses.
So if I'm in my IDE, like Cursor or Claude Code, and I type deploy this, the agent isn't just winging it.
It's executing the official SOP defined by your organization. It brings governance to the whole generative workflow.
We also saw a big update to EventBridge. The payload size jumped from 256 kVB to 1 MB.
This sounds like a small tweak, but it actually changes how you architect systems.
How so?
For years, we've had to use the claim check pattern.
Right.
If you had a message that was too big for EventBridge, like a big JSON object, you had to save the data to S3, get the S3 URI, and then put just the URI in the EventBridge message.
And then the consumer has to do another step to go download the data from S3.
Which adds latency, complexity, and cost for those S3 requests.
So with Gen AI, payloads are just getting bigger.
Exactly. A detailed prompt to an LLM or the embeddings vector that comes back from a model can easily top 256 KB.
By bumping the limit to a full megabyte, AWS is letting those rich payloads pass directly through the event bus.
We could just delete the whole save to S3 step for a huge class of events now.
Yes, it simplifies things. The event is the data again, not just a pointer to the data.
Okay, let's move to section 4, the backbone, infrastructure, data, and networking. Let's start with DynamoDB. DynamoDB Global Tables now supports replication across multiple AWS accounts.
Now, I thought global tables were mostly for multi-region redundancy.
They are. Typically, you replicate from, say, us East 1 to you West 1 to get your data closer to your users, but until now, all of those regional replicas had to live in the same AWS account.
Why would you want them in different accounts?
Organizational complexity and security boundaries.
Mm-hmm.
Think about a big enterprise. You might have a central data account that owns the master customer records.
Okay.
You have a marketing account and a logistics account that both need read access to that data.
And traditionally, they'd have to call an API to get it.
Or you'd build some complex ETL pipeline to copy it over. With cross-account replication, you can just natively replicate the table right into the marketing account. They get local, low-latency access, but the ownership and billing stay separate.
And it also helps with the whole data perimeter concept.
Absolutely.
Yeah.
You can have a disaster recovery account that is completely locked down, almost no human access at all. You replicate your production data there. If your main production account gets compromised, the DR account is isolated by a hard account boundary, not just a flimsy IAM policy. It's a much higher level of isolation.
Shifting to networking CloudFront now supports MTLS, or mutual TLS, for origins.
This is a major security upgrade, a real sign of maturation.
Explain it for us.
So when CloudFront talks to your origin server, your EC2 instance, your ALB, uses HTTPS, that's standard TLS. The server proves its identity to CloudFront.
But how does the server know it's really talking to your CloudFront distribution and not some random person on the internet?
That's the problem this solves. Historically, people use IP allow lists, which is a mess because CloudFront's IPs change all the time.
Or they'd inject a shared secret header,
Like XMySecretPassword.
which is just security through obscurity.
Exactly. If that header ever leaks, anyone can bypass your CDN and hit your origin directly. Mutual TLS means CloudFront presents its own client certificate to your origin. Your origin then cryptographically verifies that certificate.
So it's a two-way handshake. The server verifies the client, and the client verifies the server.
Correct. It's the gold standard for zero trust networking. It mathematically guarantees the traffic hitting your origin is coming from your specific CloudFront distribution and nowhere else.
Let's do one more network update. AWS Network Firewall now has web categorization and Gen AI visibility.
This is a big one for corporate IT and security teams. You can now write firewall rules based on categories. You can say block all gambling sites or block all social media.
And they specifically added a Gen AI category.
They did. So a company could, in theory, block all access to public Gen AI tools if they wanted to.
Or just monitor them.
Or just monitor them. Shadow AI is a huge concern. You have employees pasting sensitive corporate data into some random PDF summarizer they found on Google. The network firewall can now give you specific visibility into that traffic. You can see how much data is flowing to OpenAI, to Anthropic, to Hugging Face, and then apply actual policies.
Compliance officers are going to love that.
Yeah.
All right, Section 5, the lightning round. Quick updates, but with enough context so you know why they matter. First up, Amazon Connect.
Step-by-step guides in Connect now support conditional logic.
This sounds small, but for a call center agent, this is huge.
It really is. Agent scripts used to be pretty linear. Now the interface can adapt in real time. If a customer says, I want to return something, the agent screen instantly changes to show the returns workflow. It just reduces the cognitive load on the agent.
Also in Connect, new APIs to simulate voice interactions.
This is CI/CD for your phone system. You can write a script to simulate a caller, navigate in the IVR, talking to the bot, and then verify the responses are correct, all without a human ever picking up a phone.
Automated regression testing for your contact center.
Exactly.
WorkSpaces Secure Browser now supports custom domains.
This is all about branding and trust. You don't want to send your users to a weird generic AWS endpoint. Sending them to portal.mycompany.com is just so much better.
WorkSpaces core managed instances now have monthly flat rate pricing.
One for the finance teams. Hourly billing is great for bursty work. But for a full-time employee on a virtual desktop 40 hours a week, unpredictable bills are a headache. This just aligns the cloud cost with the headcount cost.
AWS Config added 30 new resource types and 13 new managed rules.
Just the never-ending march of governance. This adds visibility into things like EKS node groups and cleanrooms. Your compliance blind spots just got a little bit smaller.
And finally, AWS Outpost racks are now available in Rwanda.
This just continues the expansion of hybrid cloud into Africa. It lets companies in Rwanda run AWS infrastructure right on premises for low latency, while also meeting any data residency requirements.
So we have covered a massive amount of ground. We started with the brain Claude Opus 4.6 and the agents.
Then the body, the Blackwell GPUs, and the Xeon 6 storage monsters.
We looked at the nervous system, the MCP protocols, and the event buses.
And finally, the immune system, the MTLS, and the network firewalls.
When you lay it all out like that, the synthesis seems pretty clear. We are entering an era of what you might call industrialized AI.
Industrialized, I like that.
Is that what it is?
I think so. We're moving away from the sort of artisan phase where one developer handcrafts a prompt and just hopes for the best.
To what?
To an industrial phase with standardized parts like MCP, heavy machinery like Blackwell, and really rigorous safety protocols like the SOPs and MTLS.
That brings us to our final thought for all of you listening. We talked about how these agents are now spinning up sub-agents and following deployment SOPs. We are getting very close to a world where the DevOps engineer isn't writing the Terraform code anymore.
They're writing the SOP that the agent then uses to write the Terraform code. It's a shift in abstraction.
You become the architect of the agent, not the operator of the infrastructure.
So the question for you this week is this. Are your internal processes documented well enough that an AI agent could actually follow them? Because if your deployment process is still go ask Bob in Slack, you are not ready for this future.
That is a very sobering thought to end on. If you want to dive deeper into any of these 94 updates, please check the show notes for the direct links. We barely scratched the surface here.
Go read the docs. Keep building.
Thanks for listening to The Deep Dive. We'll see you in 2 weeks.